Bismillah ar-Rahman ar-Rahim. Welcome in this new meeting of Egyptian Society of Nephrology and Transplantation, online CNA meetings on our usual date and time, Wednesday, 9 p.m. I really would like to thank Professor Mohsen and Professor Gamal Saadi to stick to the time in spite of all the conditions that I know. Thank you really for sticking to time for our platform and insisting to make this meeting in its predetermined time. Today is one of our critical appraisal sessions, which started in one session before, was by Professor Mohsen, and this is the second one, which will be about the confidence interval. What's the confidence interval? How to calculate, what's the significance, how to use, and etc. We expect a great lecture and a great session, as our moderator is one of the great Egyptian researchers, Egyptian, African, and international researchers, well known in the field of research worldwide. He is Professor Gamal Saadi, Professor of Nephrology and Internal Medicine, Cairo University, and the current president of African Society of Organ Transplantation, the past president of Egyptian Society of Transplantation and IFKF. He will introduce our great speaker, Professor Mohsen, and will lead this meeting, and I will leave the floor to him. Welcome, Professor Gamal, and excuse me, thank you again to stick to the predetermined time of this session. Thank you so much. Please take the floor.
Thank you very much, Professor Yasser, for the very kind introduction. And actually, we are privileged tonight to have Professor Mohsen Kossi among us. He is a very meticulous, very scientific, and very enthusiastic physician. And he is targeting a very crucial and very important topic today. We might all be going through any clinical trial or any paper, and we get the conclusions out of the results. Probably many of us would go to the abstract of the paper and evaluate it from its title, not even going to the abstract. It might be very important to analyze these data to see how powerful these data are, how to depend on them, and most important, that these studies are the background or the backbone of re-innovating the evidence-based sciences and renovating the guidelines. This is a very difficult task, which is going to be tackled by Professor Mohsen, and I believe it's one of the most important topics I always like to hear and consider evaluating and benefiting from his presentation to evaluate the studies we are reading every now and then. Professor Mohsen, the floor is yours.
Thank you very much, Professor Gamal, for the introduction and for having the same feeling like me that it is a bit difficult topic. And I will just try to introduce it from the clinician perspective, rather than from a statistician perspective or mathematician perspective. Thank you, Professor Yasser, for the invitation, and thank you for the introduction. I really appreciate and enjoy joining these meetings. Regarding the confidence interval, when we are doing a research, we usually aim to get some inferences from this research and conclusions, and to apply these conclusions into the particular group of patients. When we don't do, obviously, in the real world, we have to do it on each individual of this specific group. But this realistically will not happen, will never happen. So what we do, we take a sample from the target group and do our intervention or our research and come up with conclusion. But the reality is, none of these samples that we take will be representing exactly the whole general population. So how we can overcome this type of problem? So our application for the intervention could be applicable to the whole group of the population without having a lot of harm. So we have got two types of errors when we are just practicing our research: a systematic error, which we call it bias, and random errors. The systematic errors, there are a lot of measures that we can tackle these systematic errors or the bias. Say, for example, by the randomization in the randomized control trial, blinding, and so forth. There are some sort of measures that we can do to avoid or reduce or minimize the systemic system. What happens usually? We take this sample, but this sample is not 100% representative of the overall group. How we can make sure that our sample is as close as possible to the original group. Say, for example, we have got sample 1, and we try to calculate the mean of the EGFR for the total adult population in a city. And then we collect a sample, which is sample 1. We will get a mean for this sample 1. It definitely will not be exactly the same like the overall group. And we have got another sample, sample 2, we have got a different mean. And we do our intervention. Each time we will have a different parameter and a different value for this parameter. So how we can overcome this problem? Here it comes the role of the confidence interval. How it comes? Usually it takes into account the variability or the random error that I referred to initially. Systematic errors or the bias, there are some measures, and it is not the focus of this discussion. But the random errors or the variability in sampling could be clearly highlighted in the confidence interval. How this happens? The confidence interval is usually composed of 3 components: point estimate, which is the central part, and interval estimate, which is the upper and lower bound of the confidence interval, and the confidence level, which whether it is 95%, 90%, or 99%. How the confidence interval, it takes into account the variability in sampling. When we are doing the mathematical calculation of the confidence interval, we have got the mean of the sample plus minus a correction factor, whether it is Z or T, plus times the standard deviation across the square root of the participant numbers. So in essence, the sample mean that we have got, say for example, sample 1, it is not equal the overall group mean. It equal the overall group mean equal the sample mean plus a sample error because of the variability in the sampling, which is, I've said about the random error. And this is the part which I refer to as the random error or the correction of this error for the sampling. Because say, for example, if we are collecting the vitamin D level in a group of patients, I'm quite sure that the vitamin D level will vary between, say, for example, collecting the sample in the morning or in the evening, between those who are having scarves or not having scarves. Exactly the same if we are doing the BTH. If we are collecting the sampling in the morning, completely different from the evening. So this variability in the sampling, it has been taken into account during the calculation of the confidence interval, not like the p-value or the hypothesis statistics. In the p-value or the hypothesis statistics, it gives only only single answer, yes or no, whether it is statistically significant or not, whether we are accepting the null hypothesis or we are rejecting it. This is the value, this is the p-value. But in the confidence interval, we are taking into account the other variables in the sample collection. As I've mentioned, the standard deviation, the number of the participants, and the correction factor. What does it mean? The confidence interval, if the number of participants very huge, then this total number will be less and the confidence interval will be less. What does this mean? It means that the precision or the certainty of the value of this confidence interval or the population mean will be close to what it has been in the sample mean. Very close. If this number is low, this overall number will be large and the confidence interval will be large, and the variability within this confidence interval will be huge to the point that I am not that certain about the value of the estimate, the point estimate or the mean of this sample compared to the original population. So there will be huge variability. The p-value doesn't take into account this issue. I mean, you can have the p-value which is significant for a small number, and when you just take the number as from, say, for example, 10 participants to 1,000 will become non-significant simply because of it changing the number of the participants. This is not happening in the confidence interval simply because we are taking into account this number of participants in the calculation of the confidence interval. What else it takes into account in the confidence interval to make sure that the precision or the numbers that I'm getting from this sample is very close to the general population number? It is what we call it the correction factor, which is the Z factor. This correction factor, we say that if it is, we are saying that 95%, 90%, or say, for example, 95%. There are different numbers for each level of these numbers. If it is, say, for example, 95%, the Z value will be 1.96. And if it is 99%, it will be 2 plus something, to just multiply it by the standard deviation divided by the square root of the number. So this correction factor will increase the overall number if it is high, and it will decrease the overall number if it is low. The rest of the things that could take into account the standard deviation of this sample, which is the variability within these groups of the population. If, say, for example, the variability is huge, then the confidence interval will be huge. And this means that the precision or my level of confidence about that the numbers I'm getting from this confidence interval calculation will not be that matching the original population. So as I'm saying here, that the population means doesn't equal the sample mean, but it equals the sample mean plus minus the sample error, which we have calculated it already in this Z, which is the correction factor, times the standard error of the mean, which is the standard deviation divided by the square root of the number of participants. What do you mean by this 95% confidence interval? We mean that we are 95% confident that if we repeat this test again in a different sample, we will find the point of estimate of this population within this interval, within the high and the lower bound of this interval. Obviously, the most closest one and the most appropriate guess will be the point of estimate itself. The point estimate, which is the central point. This is the closest guess to the original population. But all these could be potential possibilities for the mean of the original population. So we have to be taken into account that this 95%, it will include the population mean in a 95% confidence or in a 99% confidence. Why we usually take it as a 95% confidence? I will just come to this in a single figure. So we are 95% confident that the true population mean lies between sample mean plus minus 2 standard deviation of the mean. Or in other words, we can say it again, 95% chance that the true population mean lies between the upper and lower boundaries of this confidence interval. What affects the confidence interval width? As we said, if the confidence interval wide, very wide, this means that the variability or the uncertainty within this population is huge, and I will not be certain. But if it is narrow, this means that the precision and the variability is less, which means that I am pretty confident that the population mean of this sample will be very close to the population mean of the original population. So if the variation is little variation, we'll be having similar samples and would be more representative of the whole population with a narrow confidence interval. Larger variations will have the opposite effect. We mentioned about the sample size. If the participant number is huge, this means that the variability will be evened out. If it is evened out, then it will disappear this huge variability and the confidence interval will be less. But if the sample size is small, the variables will be very evident, and you can have a huge variables, and I will be not certain whether the population mean will be within this interval or it might be even outside this interval. What about the confidence level? We said about it, if it is 95%, obviously better than the 90% in the precision, and the 99%, it is better than 95%. We mentioned about the sampling error, which the confidence interval can reflect some of this sampling error, and it is inherent in its calculation, but doesn't do anything about the systematic error or the systematic bias. What affects the sampling error? The random effect itself, whether we are taking it in random or not random. Obviously, usually we say that it should be a normally distributed sample. If it is normally distributed or skewed, this means that definitely the sample will not be precisely represented in the confidence interval, and the confidence interval will be high. And this, you can see the sample size effect here for the confidence interval. Here, if it is, say, for example, 10 participants, the length of the confidence interval or the estimate interval, this is the estimate interval, will be very huge, and the uncertainty will be high. And if it is the participant number is 1,000, all the variables will be, or the variabilities within this sample will be evened out and will disappear. And then that's why I will have a narrow confidence interval, and I will be more certain that the population mean of this target group will be within this estimate interval. Why now the 95%? If we remember from the basics of the statistics that we have got what we call it the type 1 error, which is the false positive. We accept that the alpha error or the type 1 error at 5% to reject the null hypothesis or to be significant, and the 95% to be true positive. The probability margins usually between 0 and 1. If we take 0.05, which is the false positive, from the whole one, the remaining, the true positive, will be 95. That's why we usually, for the confidence interval, we use the 95 as a rough guide, or I mean rough estimate, that most of the population mean should be included within these boundaries. Also, we know that in the normally distributed samples that 95% of the population will be lying around the 2 plus or minus standard deviation around the mean. So the 95%, and this is another reason why we are taking the 95% as a standard for the confidence interval. But obviously we can make it as a 90% if we would like to be more flexible and taking the variability, or we can make it more tight by saying it is 99%. So what is the difference now between, this is the definition obviously of the confidence interval. It communicates how accurate the estimate is likely to be compared to the general population, which we don't usually do the general population, we do just only a sample. The confidence interval, say for example for the mean, if the mean of your estimate plus or minus the variation in that estimate, this is the range of values you expect your estimate or point of estimate to fall between if you redo your test in many occasions within a certain level of confidence, which is the 95, 99, or 90%. Why we are interested in the confidence interval? simply because it doesn't say significant or not significant, like the p-value. The p-value, we have been reliant on the p-value up until 1985, 87, until this confidence interval has been introduced after that. The confidence interval, it gives you the significance, the level of significance, whether it is significant or not, like the p-value. And also it gives you some more important information about whether it is clinically significant or not. And I will come to this example in a minute. So the evidence-based medicine is now reliant on the estimates of confidence interval. We don't rely anymore on the p-value because of the problems of the p-value, systematic bias, or the systematic errors. We can't precise it from the confidence interval, but the random errors we can. We know the hypothesis testing, which is the p-value versus the estimate, which is the confidence interval. And we will just tackle this question in a minute about what the importance of the confidence interval in comparison to the p-value other than the significance. The point estimate, which is the central part of the values. And for the point estimate itself, it doesn't give us a clear information about the size, but when we combine the point estimate with the interval, it will give us some more information about the sample size and the variability, obviously, and the certainty. The interval will contain population value with certain level of confidence, and we said about the 90, 95, and 99, and we said about the confidence interval versus p-value. Now, usually we use the confidence intervals when we are making a difference or making a ratio. Say, for example, a difference in a mean, or hazard ratio, or odds ratio, or relative risk. When we are doing a difference of mean, if, say, for example, we are making a difference between group X and group Y, if they are totally equal and there is no difference between them, so X minus Y, how much it will equate? It will equate 0. So if the confidence interval contains the number of 0, this means that it is not significant because both groups are exactly the same. If we are talking about a ratio between two groups, so if we are saying group X and the group Y, and the ratio is X over Y, when they are both equal, how much is the value of this ratio? Will be 1. So if we are talking about 1, and this 1 will be in the interval of the confidence interval, this means that it is not significant, simply because both groups are exactly the same and equal. So if it is the 0 number is within the confidence interval for a difference, or the 1 number, it is available in the confidence interval for a ratio, this means that this confidence interval is not significant because both groups, they are the same. What about this clinical importance about the, we know that it's statistically significant now if it crossed the 0 or it crossed the 1. But what about the clinically significant? Usually when we do the sample size, we take into account something called minimum important difference. We don't accept this intervention or this drug in this population unless it makes a certain level of difference between the other group or from the other group. If, say, for example, we are comparing an open surgery for a laparoscopic surgery for cholecystectomy, and then we said that if the pain score at least 10 difference between both approaches, then we will accept that the laparoscopic surgery is superior in favor instead of taking the open surgery. When we do the sample size calculation, we take into account this minimum important difference, okay, which we are usually taking or tackling it in the confidence interval, the number of participants. So what will happen? What will happen? Say, for example, I have got these 4 studies comparing both approaches. I've got a study 1, a study 2, a study 3, and study 4, and I am comparing the difference between both, and the threshold for clinical significance is 10. First of all, if we look into study 4 and study 3, they cross the 0. So they are both statistically not significant. So this doesn't mean that I will take them as there is a difference. There is no difference between both groups. And don't forget that this one, study 4, has got a very wide confidence interval, which means that you might need to reduce this variability by increasing the number of participants. So you might need to redo this research or this piece of work by increasing the number of participants. It might reduce a bit the level of confidence or the variability within the group. But both of them, they don't contain at all the level of the clinical significance, which is the 10. So that's why they are both statistically not significant and clinically not significant. So if we come to the study 2 and the study 1, study 1, both of them, they are statistically significant simply because they both difference between two groups and they both cross the number of the 0. What about the clinical significance now? The clinical significance, you can see that the difference of the minimum important difference of the 10 is included within the study 2, which means that many of the difference between two groups, they will have the same difference, which means that this is clinically not significant, this study. And I have to repeat this study again with a larger number or to reject the hypothesis that the laparoscopic operation is superior to the open surgery. If I'm looking into study 1, it is all of the participants here, they are achieved a score of more than 10 as a difference, and the narrowing of the confidence interval makes me confident that the result of this study makes me favor the laparoscopic surgery against the open surgery. So study 1 is both clinically and statistically significant. Study 2, it is statistically significant but clinically not significant, and you might need to repeat this study by more participants. And the study 3 has got not significant clinically or statistically, as well as study 4. You can stop me at any time if there is anything is unclear. Coming back to another example. If, say, for example, we are using two types of diuretics, A and B, and we are assuming that the minimum acceptable difference to say that diuretic B is better than diuretic A if the urinary sodium excretion per 24 hours is more than 500 millimole. So what happens if we look into the study 2? It crosses the 0, so it is not statistically significant, and it's clearly very wide, which means that you might need to repeat this study again with a larger number of participants to ensure that we are addressing the problem of the uncertainty in the sampling or the sample error. If we look into study 4, again, it is statistically significant, although the number of the participants quite okay, because we can see that the difference of the 500 is above all the participants here. So it is clinically not significant and statistically not significant either. Okay, the same for study 3. But if we go to the study 1, all the participants, definitely it is statistically significant because they crossed the 0, the value of 0. And don't forget that this value will be 1 if it is a ratio, like the odds ratio or hazard ratio or relative risk. And the minimum accepted difference of 500 is achieved on all participants because all of them, they are more than the 500. They have achieved 1,500 up to 2,000, which means that this is clinically significant and statistically significant. If we look into this one, it is it is statistically significant, but clinically not significant, simply because both groups didn't achieve the expected or the recommended target level of 500, and I will reject both drugs, and I would say that they both the same, doesn't make a huge difference. What I've meant about the correction value to make it 95 or 99 or say for example 90% confidence interval. This correction value, we change it from Z to T if the sample size is less than 30. If the sample size is more than 30, we'll use the Z score rather than the T score. And we have got tables for the T and we have got table for the Z for each level of confidence interval. And we can use also the T score for when the standard deviation of the population is unknown. So to conclude, the confidence interval now, it is a requirement for research reporting by most high-rank journals. The concept, which is the statement of reporting any clinical trial, which is the gold standard for all guidelines, recommends the confidence interval in reporting any research result for the randomized control trial. Quorum, the statement for reporting systematic review and meta-analysis, again, which is commonly used in the guidelines statements, they recommend the use of the confidence interval. We should be very cautious that the value of the confidence interval shouldn't exceed certain numbers. What I mean by that, say for example, if we are talking about the confidence interval for the area under the curve, it shouldn't exceed 1. And if we are talking about a ratio or probability, it shouldn't exceed 1 or 100%. Okay, and it shouldn't be less than 0, simply because the probability usually lies between 0 and 1 or 0 and 100%. When we are reporting the confidence interval, we have to be very careful in what? In estimating the confidence interval or referring the confidence interval not for each group. Say for example, we have used, an intervention for 2 groups. Please don't provide or report the confidence interval for each group separately, because this will not mean anything. Just present the confidence interval of the difference, which will mean everything. The confidence interval of the difference, or the confidence interval of the ratio of both groups. Don't mention the confidence interval of the statistics of each group separately. We don't take the confidence interval, is it crossing the 0 or the 1 or not, because in this way, we will be just taking the same thing like the p-value. Is it significant or not significant? But we don't take into account the sample error or the variability in the sampling, as well as the clinical significance. I believe that I have done, and thank you. I know that it's a bit tricky topic, but I am open for any question.
Thank you, Professor Mohsen. Professor Gamal,
thank
please.
you very much, Professor Mohsen, for very thank you very much, Professor Mohsen, for this very tough subject you I have is very wide variety among the you mentioned that we should consider reducing the sample size. I'm a bit worried about this. Should we, on the contrary,
sorry, Professor Gamal, the voice and the sound doesn't seem to me personally there is a problem. I don't know whether this is a personal issue or it is everywhere. I don't know.
Can you hear me now?
I can hear you now. Yes.
Yes. You mentioned that when we have a wide variability of the data, we should reduce the sample size to have better interpretation.
No, we should increase the sample size. We should increase the sample size.
We should increase
the sample size. Yes.
Okay. So
yes.
I understood it in the wrong way.
Yeah. So the equation is the standard deviation over the square root of the number. So if the square root of the number is huge, the overall value will be less, and the confidence interval will be less.
So increase the sample size. Yes.
I have a question, and
ask you about another issue. If we are comparing data of 2 different studies, should we consider the duration of sampling, whether data were collected over 3 months, for example, versus data collected over 6 months in our evaluation?
I mean, this is something out of the scope of the obviously the variability, but again, it depends on the nature of the study that you are talking about or the outcome that you are looking at. Say, for example, you are expecting the outcome to happen after 6 months, or you are expecting the outcome to happen after 18 months. For example, the SGLT2 inhibitor, most of them, you can see that the separation of both curves will happen after 12 to 18 months. So if you do the study over 6 months, you will not find any statistical significance.
No. So my question is that if I'm expecting the data to, or the outcome to be after 1 month, for example, but the collection of samples was over a period of 3 months and another study over 6 months, but the same expectation of the results, would this have any impact on the confidence interval?
No, will not have any impact. I mean, because the duration is not into account of the variability, because each one has got its own confidence interval.
But my question considers that the longer the period, you might have other variations in the circumstances of the study you are encountering.
And in this circumstances, and in this case, as I have mentioned, it depends on the outcome. So if you are expecting the outcome will differ if you are in a short interval of monitoring, or it will not happen unless you have got a certain amount of time, then definitely you have to refer to that when you are comparing the studies.
This leads me to,
and the confidence interval result definitely will differ.
This leads me to another question about considering data of a single center to be compared when you are interpreting data from a multi-center study.
Yes, definitely.
Does it have any impact?
Yes, definitely. And that's why the confidence interval, when it comes on its own, but it will give you some sort of, precision or certainty about this in comparison to the general population. That's why they are overcoming this problem by what? They are overcoming it by the multinational randomized control trial. If, say, for example, you are doing the trial in the Middle East, and you don't do that in Europe, or you do it in Europe, but you don't do it in the States, they usually, the outcome of this trial or the results will not be, applicable or extrapolated to the whole population. And you will be making a reservation. I'm not sure whether this will work on the other population or not.
Excuse me, Professor Mohsen.
Do we have any questions coming to Riyad?
I have a question for myself.
Yeah,
please. Professor Mohsen, excuse me for this question, but I really want to clarify this point.
Yeah.
Changing the confidence interval then 95% if we cannot reach the proper sample size according to 95% CI. Do you agree with this or do you not?
No, I couldn't get your question. Can you please repeat it again?
You said that it is 95%. We use the 95% confidence interval, okay?
Yes.
And this helps in calculating the sample size according to the calculating sample size, okay?
Yes.
Sometimes we cannot reach the proper calculation of the sample size due to
repeat the question again, Dr. Yasser, please.
Professor Mohsen said that we have.
Could you repeat the question?
Yes, I'm repeating. Sometimes we use usually 95% confidence interval, and this the sample size is calculated according to this. Okay, is it? I'm right or not?
Yeah, the question is the sample size not calculated depending on the confidence interval. The sample size is calculated according to the type 1 error and type 2 errors and the minimum clinically significant amount. But the confidence interval determination, which is the 95 or 90%, it is your decision. How would you like to feel about the precision of your results? Whether you would like, and that's why many studies, they can make it as 90%, not 95%.
Yes, this is my question.
Yeah.
So if I change this CI to 90 or 95%, do you encourage this? Or sometimes.
I mean, repeating the research project.
Yes.
After you do, it is a very exhaustive problem, and that's why probably we might need to do, a proper analysis and a proper design before we go ahead. So if, say, for example, you are accepting the level of confidence at around 90% from the start, and you are expecting difficulty in recruiting participants, I would go for 90%.
Yes. So this is my question. We can use it. We can go down sometimes to difficult due to difficulty in recruiting patients.
Yes,
recruiting
definitely.
Yes,
And
this is my question.
I mean, and the reader will be aware that
That
this level of certainty here will be less than the 95%.
is this lower limits or
There is no lower limit. There is
no
no
lower
lower
limits,
limit.
only affects the precision of the
Yes,
of
it
the
will
result.
affect just the precision of your results. What I mean by not that doesn't do anything with your results, obviously. It just affected the precision of what you
The
got.
precision.
Yes.
Yes.
Whether
Yes,
this, say,
yes.
for example, the mean that you have got is closer to
Yes.
the general population mean, or it might be, no, it's not. I mean, the certainty is reduced, definitely. But 95,
Okay.
the certainty is higher. 99, the certainty is far higher.
Yes, this is exactly my question. Thank you for getting and answering. Thank you. No more questions and no more comment, Professor Gamal?
I have one more question, Professor Mohsen, please.
Yes.
When you are analyzing meta-analysis,
yes,
would the confidence interval of one study have an impact on another study of more confidence?
Oh, yes,
a study of lower confidence will lose the importance of another stronger study.
Yes, definitely. But at the end of the day, you have got to present your meta-analysis at the end, including all the studies. And you will see that this study has had a very huge confidence interval, and it was, say, for example, not significant, but this study has got a very narrow confidence interval and more reliable compared to the other study, even if it affected the overall outcome.
Do we need to exclude data from studies or from meta-analysis which are of weak confidence interval before analyzing the data collectively?
If the design of the study has done accurately, then I have to go for it. If the design has been, because when you are doing meta-analysis, you are doing a certain set of criteria when you are searching for the studies. And you say that, say, for example, I am collecting the data for all the studies done between 2020 and 2023. So you can't remove this study unless there is, a fault or a problem or a question mark of the design to say that, oh, I can't include this study simply because there was a problem in the blinding. There was, a problem in the dropout rate. So you can't rely. Here, the study, say, for example, it was not intention to treat, which is completely different from the other studies. So it depends on how harmonized this study compared to the other. But if it is well designed and it has been doing the same blinding and the multinational, then why not to take it? Because you have got the set of the criteria before starting the search to include any study of the type.
Could you enumerate the criteria of filtration of the studies to be excluded from the meta-analysis?
Definitely. And this is the methodology. In the methodology, you will say, I'm not going to accept this type of studies. Say, for example, if the number of participants less than 1,000. And this will, by default, will exclude those with a wide confidence interval. Say, for example, when we did the UK guideline for SGLT2 inhibitor, we excluded completely any trial for a study with less than 1,000 participants. And we have taken any trial more than 1,000, because we know that 1,000 number for a randomized controlled trial of this type will be misleading.
Thank you very much, Professor Mohsen, for this very comprehensive clarification of a very tough topic. And I think if we revise the question panel, Dr. Yasser, are there any questions?
No more questions and no more comments, Professor Gamal. Excuse me.
So I think we had a great book from you, Professor Mohsen. Very comprehensive, very clarifying, and I think it is very crucial in our evaluation of the papers and studies we are reading. And it is very important and crucial to consider the evidence-based guideline implementation. Thank you very much.
Thank you very much. It's my pleasure. It's my pleasure.
Thank you, Professor Mohsen. Really a very important lecture and very important session. Will be reserved for the teaching tool for all researchers to start with, to identify the confidence interval and what is it and what's meaning and how to deal with. Thank you, Professor Gamal, for leading this session in a very, very smart way. Thank you very much for this very interesting session. And excuse me to close and announce about this. Thank you, Professor Mohsen. Thank you, Professor Gamal.
Thanks a lot. Thank you very much.
Our next session will be, inshallah, next Wednesday.
Welcome, all of you.
Thank you.
Thank you.
Our next session will be coming Wednesday, inshallah. Will be session of peritoneal catheter by Professor Tamer Wahid Saeed. And see you, inshallah, next Wednesday. Assalamu alaikum wa rahmatullahi wa barakatuh. تصبحوا على خير. شكرا جزيلا.
Thank you very